All right, so here's a few news links. We got about 10 minutes here. So they're going to make a documentary about Jamal Khashoggi, who got killed in Saudi Arabia, or killed by the Prince of Saudi Arabia after he had left, and it made a huge scandal. And the point of this documentary is not only that he's terrible and he did a rotten thing, but that any American company that does business in Saudi Arabia is equally culpable. That's the argument of this. So we'll see how this goes. I can expect a lot more political backlash coming out of that. Google has a secret manager now, which is like Apple Keychain. You can put secrets in the cloud. And the idea is this is a huge problem for many companies. You have stuff like your API keys for Amazon and all these secrets, and you don't really have a good place to put them to share with your enterprise. So Google Cloud will now give you a cloud-based centralized key management system. So that sounds interesting. And of course, it's a single point of failure. And so anyway, it is certainly an interesting offering. This is a question I've been asked often. A lot of developers hard code keys and passwords. And then they say, well, what else can I do? And it turns out that the alternatives are kind of annoying and inconvenient. And so this is another opportunity another option, where to put your secrets. This one is kind of amazing and very much like Microsoft. You may remember a few years ago, Microsoft wanted everyone to go to Windows 10. So they started popping up boxes that say, do you want Windows 10? Yes or no. And even when you click no, they would just put Windows 10 on instead. They like to do this. So now they're doing this. They're going to forcibly change your search engine to Bing in Chrome if you use Office 365. And they're saying this is because there are all these search features that will search through your Office 365 documents, and those won't work unless you're using Bing. So you really want to use Bing. But they're doing it without telling you. So, you know, this is pretty rapacious. And I was just listening to a podcast from a lawyer. There's now a lot of movement to try to regulate the tech giants, mostly because of Facebook and Cambridge Analytica. And they're trying to use antitrust laws against the tech giants. And they're trying to stop this kind of thing. And they have testimony from companies that have been crushed by Google and Amazon. There was an Amazon company where they had a product, Snap something they made, and they sold them on Amazon. And Amazon decided to lower the price below their price and tell them they were going to charge the customer like $5 less, and you're going to pay us the difference. They said, we never agreed to that. Why would we do that? They said, fine. Then we're going to take your product off and let people put up fake product, pretending to be your product and not warn the customers, so they're going to get knockoffs. And that's what they did until the company went broke. And Apple has done this many times. They will delay, you'll apply to the store, they'll hold your product for 6 months and review while they clone it. Then they'll put up their clone and rejectors saying it competes with theirs and stuff like that. The big companies have done this all along. Microsoft used to do this all the time in the 90s until they finally got clobbered with antitrust. And they're planning to clobber them pretty soon again with antitrust. But of course, that will all depend on the next election. If the Democrats, like especially Warren, gets in, then there'll be a lot of this happening. If Trump gets in, then it probably won't happen. But anyway, so there's a lot of monopoly abuse going on right now with the huge giant companies.
It's called creative monopoly.
Yeah. And so what they said is a lot of the actions are not exactly illegal, but they're thinking of having categories. Like you cannot run a search engine and make the products like Amazon. You have to do one or the other. So that might be one way to go. Anyway, so this is the big scandal today. Bezos claims that MBS, the Crown Prince of Saudi Arabia, hacked his phone. And he has a timeline. He said when he started publishing a story in the Washington Post about that Khashoggi thing, then MBS went somewhere with a conference and became his friend on a WhatsApp or something, or Telegram or some one of these instant message, and then sent him a video out of nowhere. And when he played that video, then his machine was hacked and this guy started knowing secrets he shouldn't know. But they didn't really find malware in the video. They just found that his phone had a higher degree of network traffic leaving from that point on. And other people have been analyzing it and saying, there's a lot of things that makes your phone have extra network traffic. That doesn't really prove he was hacked at all. And so they're making a big splash about this and how this proves that the Crown Prince personally was involved in hacking his phone.
Hello?
So people are saying, I'm not so sure this evidence is that convincing.
Hey, Dominic.
But that's one of the latest.
I didn't know she was calling you.
Anyway, these are patient monitoring devices used in hospitals. And this is the big thing that the I Am the Cavalry project is all about. There's medical devices are ridiculously insecure. And these have the most common vulnerability, which is just hard-coded, unchangeable credentials for things like SSH. So they warned them years ago. Most of them don't have a good update process or anything, so it's very hard to fix them. The medical community in general has only thought about patient safety in medical terms and not about cybersecurity. And there's tons of these products that have ridiculous vulnerabilities that are just beginning to be revealed. So there's a big botnet that's been around for years, and someone is now hacked the botnet, and they're removing the malware and popping a box telling people they add antivirus. So this appears to be a rival crime gang crushing the action of a previous crime gang, or it could be a white hat hacker. There are people who try to save the world by forcibly removing malware from other people's machines. There have been at least 3 cases of people who wrote a counter virus to infect and clean infected machines, and then it went out of control and made a problem worse than the original problem. But this sort of thing does go on all the time. Of course, unauthorized repair is technically as illegal as doing the unauthorized action in the first place, but in practice, you might be able to defend yourself in court. I don't know. Anyway, New York State wants to ban government agencies from paying ransomware. This is the current situation. Almost everyone that gets infected with ransomware just pays the ransom. Even if they have backups, they usually find out that paying the ransom is cheaper than going through the tedious backup restore process. And although people tell me that 40% of the time, even when you pay the ransom, you do not get the key. But everybody in this business tell me their clients frequently just choose to pay the ransom. It's cheaper than the alternatives for most of them. So anyway, of course, that encourages the bad guys. So we'll see. If the government agencies get forbidden to pay the ransom, then you would think that would begin to choke off the ransomware a bit. Anyway, these DNA tests sales are declining. Boy, I'm glad to see this. Don't do this. I can't think of any stupider thing to do than let these idiots sample your DNA, put it in the cloud, let everybody steal it, and now everybody in your family forever is trackable. This is like a serious invasion of all the privacy of all your children that haven't even been born yet. It's not wise at all, and I guess that people are beginning to wise up, and all you're getting, the genetic scientists that look at this stuff say all you're getting is no different than like tarot card readings. Their ability to actually determine anything of value out of that stuff. I remember my friend did it and said, you're like 10% American Indian. And then a few months later, he said, oh, no, we changed it. You're only 1% American Indian. And then he changed it. They have no idea what they're doing. They're just making it up. The evidence linking your DNA to anything important to you is so fragile right now. And the cost of this is so high. I'm glad to see it declining. This is an unwise trend. Goldman Sachs is now not going to take a company public unless they have a woman on their board or some other kind of diversity. This is the kind of quotas that the right-wingers of all my life have complained about. But I must say, I'm watching the effective diversity on our cybersecurity team. The winning teams are always the teams with women on them. And the diversity proponents have always said you should just have quotas, forcing you to have them, because the fact is your idea of measuring quality of people is so inaccurate that it's a lot more racist than you think. Anyway, but they're going to try doing it. We'll see how it goes. But that's their plan. Anyway, and I think that's enough of this. So let me point out some stuff about the administrative things on the class. So here, this is 129S, and anybody that wants to add should be able to just add. All right, I showed you last time the first project, and there's an extra credit part of the first project, and there's some other extra credit projects I want to show you. But I'm going to start by going through some of the defense mechanisms here. So let me find my slides. Oops, get rid of that. Get rid of all that. Here's my slides. Okay. There, chapter 2 will do. All right. All right, we got down to here last time. So let's start with this stuff. All right, so to defend yourself, remember the fundamental problem is that people are sending all kinds of data up to the web app, and the web app is then passing it from one server to another, changing the language and everything else until it gets confused, and it turns out to be pretty easy to trick it into doing something wrong. So you can prevent users from seeing pages with important functionality like administrative control panels. You can limit what they put in to remove bad characters and such. You can have administrative monitoring, which is really important. And we have a network security monitoring class this semester because you should know that none of your defenses are actually going to work 100% of the time. They're just like the guards at the gate and everything else. They stop some attackers, but some attackers get through. So you should be monitoring your network to see who got in and then responding to that with incident response. So the big things you want to do here are authentication, so you know who people are, then session management, so you keep track of who they are as they wander through your application, and access control, so that everything that is important is restricted to only authorized users. All these things are frequently done incorrectly, but you need them all to be done correctly. So authentication is when you, identification is when you claim to be somebody, and authentication is when you prove it with some kind of proof like a password or a fingerprint or something. The most common is a password because it's cheapest, but it's also the least secure. It's very easy to steal passwords. You can find online dumps of millions of passwords, and if all you need is a password, then it's relatively likely that a bad guy will be able to get through that. What's better is to have two factors, password plus a key, a hardware token you carry around like YubiKey or something like that. Child certificates are another good option, smart cards, all these things. And once you have passwords, you now have to have some way for people to register for accounts, and you have to have some way for them to recover lost accounts, and so on. So you log in with username and password like this, send it up to the server. And now the problem is you usually have a predictable username that's easy to guess, and you often have a password. People often guess like something like 5% of people just use 1, 2, 3, 4, 5, 6 or something. So a lot of passwords. So if you can guess, say, 1,000 usernames because they're just using like common human names, then you can just try dumb passwords for all those 1,000 usernames and you'll get in. This is called password spraying. Another thing you do is just take a dump of stolen passwords from another account and figure they reused the same password, because a lot of people do. So it's actually fairly likely that an attacker will get in pretty fast into somebody's account if they try, if all you have is password-based logins. Now, session management is where you keep track of, here, let me see if I can do anything about this Zoom thing being in the way. All right. So this is where you have to keep track of who a person is as they wander through your app. And usually you do it with a cookie. This is why Netscape added the magic cookie. Or HTTP is an intrinsically stateless protocol. When you send a request, you get a page, and nothing about the protocol keeps track of who you are. So when another person sends a request, they just get the same page. And that was okay before people had any personalized content on the web, but now it's not. So one common mistake is the tokens are predictable. You just number them. This is user number 1, user number 2, so I can just change that number and get it somewhere else. Or you handle the token poorly, like sending it without encryption, so I can steal it off the wire. So each request has to be approved or denied. You should have permissions on each important object. Many people don't. And input validation is the most common security control. This is very often trusted too much. So you say you must have 4 letters here. You also have an email address here with an @ sign in it, must contain only numbers. Now, this is what you often have to try to stop people from transmitting invalid data. And you often enforce it with client-side JavaScript, but you cannot trust client-side JavaScript. The user can overcome it, for example, by using burp. They can run your form, submit it, then intercept it in burp and just change it to anything else. And so you can't trust that your client-side JavaScript has actually limited what happens. You have to validate it again on the server. And a large number of people make this mistake. When you're a developer, it is very easy to lose track of whether an operation was done on the client or on the server, and whether data has been bounced off the client and come back or not. It's very easy to forget about that, and you end up trusting something that actually came from an untrusted source. So people are putting up blog posts and cookies and form fields and parameters and headers and all these inputs could have script in them, special characters and various kinds of malicious payload. So the most common technique is to try to find all the bad input and block it. So if they're trying to do SQL injection, they'll be trying to put in select. So if they just block select deliberately, you can just try changing the case, uppercase and lowercase, and that will still be accepted by a SQL engine as a command, but it might be getting through the filter. This is extremely common. These are common injection attacks, and what a lot of people do is just put them in like virus signatures and block exactly those. And what those will do is stop dumb automated attack tools used by script kiddies that just try to inject standard attacks, but they will not stop a more intelligent attacker who's willing to put variations in it, which will not match the pattern exactly. That's why blacklisting is considered a very weak technique and is just a minor challenge for the attacker. They just have to find a way to scramble it a little bit so it doesn't appear on the blacklist anymore. What's considered a lot better is whitelisting, where instead of trying to identify all the bad things and block it, you identify a set of characters that are good and let nothing else through. That's safer. Then anything weird is just removed. And I only take things that are on my list of known acceptable good inputs. So sanitization, this is unfortunately extremely common. You'd be a whole lot secure if every time you got some input with something wrong with it, you just reject it and tell the user something's wrong, try again. But an enormous number of web apps just take something with like bad characters in it, clean out the bad characters, and then forward it for more processing, which is kind of asking for it. You had a red flag. There was something wrong with the input, but you just sanitize it and keep using it. I don't know why people do this, probably to make it seem like it's working when it's not working, but it's great for the attacker. I can just try all kinds of stuff, you know. But anyway, so you try to make it harmless. HTML encoding is one way. Characters, each character in a URL or in any kind of input can be replaced with HTML encoding. So %20 stands for the hexadecimal value 20, which is 32, which is asking for a space. So a space becomes %20. Yeah.
Well, I don't know if you were being, what do you call it, a rhetorical question, or if it was real, but as a person who's made applications, it's often very important to do things to make it easier for a user to use, and some of that includes dealing with some of their typos and being a little bit accommodating. So there's a payoff and a give and take.
Okay, well, that's interesting. From a security point of view, I would not, but I mean, a typo is one thing, but removing something that looks like an attack should trigger another flag.
I agree.
But in general, most people don't think of this and they don't have a good mechanism for that. That's why it's a talk in the book. You should have some way to detect bad things and treat them differently, but of course that would be more complicated. Yeah. Anyway, so the big issue here is boundary validation, and we're going to get there. And basically the problem is you have to actually understand your web app and carefully consider the security boundaries, which of course means you haven't just been throwing it together to make it work. You then have to have another layer of actually understanding and planning security on it. So safe data handling would be best to actually write code that will not do anything wrong no matter what data comes in. If, for example, you use parameterized queries in SQL injection, you can adjust them so that the parameters that come in are stored in data objects, which cannot possibly be misunderstood as code objects. And this takes about 7 lines of PHP instead of 3. But then no characters they put in will ever cause SQL injection, and that's been true for years. There are safer ways to write your code, and this of course would be the best solution, is to make sure early developers are using the best practices all the time, but in practice at scale that is probably not practical. All right, so when you're validating data, you can validate in any context, like make sure that the account number belongs to the currently logged in user and so on, so they haven't changed the number partway through a session. And so you have a lot of, the problem is you have a lot of different servers with different languages and different rules, and the data is being passed from one to another, and data that might be harmless to one server is harmful to the next. Like an apostrophe is harmless in PHP, but bad on a SQL server, which is the fundamental one you exploit in SQL injection. So what's the right thing to do is to find your trust boundaries, where you have a trusted zone and an untrusted zone. You have data coming in which is untrusted from the user, then you move it into something like your database server where you need to be able to trust it, and you clean the data that passes a boundary. So you have to take, consider, so here you've got a login submission going to an application server, then you have to clean the SQL before you send it to the SQL database, and down here you got a SOAP service, so you're going to encode XML meta characters because those are the characters that would cause unexpected activity down here, and so on. And then when you send it back to the user, you sanitize the output so that there won't be any extra script running in the user's browser. That's why every time you move from one environment to a different environment, you consider what should be cleaned out of this before it goes to the next environment to make sure that no unexpected stuff gets through. And that's the logic you have to apply to your web app to be safe. It's not like there is one filtering stage that will fix all the problems, although nobody much wants to hear this. What they want to hear is just buy a web application firewall, pay the money for it, and now that job is done. Now I'm compliant. And of course, that's better than nothing, but it's not really very good because it is, in fact, a more complicated situation than just having one filtering stage able to stop all the attacks. So that's what SOAP requests look like. They're just XML. And the point of these, the apostrophes are not the problem here. It's these less than and greater than signs, which if I can put them in a name or something, then I can add extra tags here, which will be misunderstood by the XML parser. So here's the example, comes in with username and password. I allow only good characters. Then I go to a SQL query and remove dangerous characters like apostrophes. Then I go to the SOAP stage, but I remove extra less than and greater than signs. And then going back, I remove the scripts. Like I said, this is the way you do it. So there's a lot of problems. If you have an app that removes this string, I can just put it in twice, and then your filtering will take the one out of the middle and leave one behind. So just one line of grep is not enough. It's more complicated to thoroughly remove all the bad stuff. Also multi-step validation. If I first remove .. and then I remove .. to try to stop directory traversal, to go to the directory above, I can put in this .. And it will first look for .. and not find it, then look for .. and remove it, leaving .. There's quite a few of these. This is what attackers do. They learn the strange looking strings, which when filtered will turn into the bad stuff. And then you still got the injection you thought you had stopped. Canonicalization is the translating things like this. You can see this, by the way, in a browser. If you just go here, like this page, and you put in like a space here, a space between S and 20, and then press enter, it changed it. Of course, this browser changed it back too fast. Maybe Opera is simple enough not to change it. Let's see. If I change this to Sam's space class, nope, okay, I can't get the browser to do it for me anymore. Well, I'll put a question mark, 1, 2, 3. All right, I can't find a live example anymore. Browsers are getting too damn smart, but it will change that to a %20. And you can see it in older browsers. Now they're all like automatically flipping to a search engine or something. I need to get a dumber browser. Anyway, so this is just ASCII table. There's % and apostrophe and so on. So you can filter these things, but Microsoft, in one of its IIS products, I think version 4 or 5, would actually do decoding twice. So you could twice decode it, %25, 27. The %25 would be decoded to %, and the %27 would become an apostrophe. So you could put in that mess, and it would do SQL injection because it would be interpreted as an apostrophe. Decoding, this is the problem. So, all right, these are the general problems you have. Then there's other things. You got to handle errors in various apps, and you don't want to put too much information in the error message. You're going to have audit logs somewhere, and those are confidential. And you should have some way to alert administrators when somebody is attacking you, and some way of reacting to an attack. If you get many, many malformed requests from the same IP address, you really ought to do something other than just keep processing them. So one common mistake in websites is error messages tell you stuff like dump out line numbers and code and such. Many years ago, I think around the time Obama and Hillary were running against each other, I decided to look at the political websites. The Democratic website was okay, and I went to the Republican website and I put an apostrophe in the URL, and it turned into a giant screaming red page of source code. And I said, I think I'm not going to mess with this anymore. Someone's going to get mad at me. But it was just running on a Windows server. It was total crap. It would dump out pages of screaming red ASP every time anything a little weird happened. And, I think it's better now. But it was just set up by somebody who didn't know what they were doing. And I wasn't sure of the legal status of this, which is in fact somewhat questionable. So I decided to knock it off for a while. So you got audit logs recording what people have been doing. And these often contain information like cookies from users and such. There was a fun attack against Elma servers. Elma is a common Windows-based log format. And you could just send someone a link to go to, I think, Toyota, and put an apostrophe in the URL. So when they click, it'll go to Toyota and cause an error, which goes in their error log, which has their cookie, if they're a logged in Toyota user. And then it's an invisible error log, which is by accident public to the whole world. So you could steal anybody's cookie that way. That's right. People don't think about this. And I've been auditing iOS apps for the last several weeks, and I found an iOS app that had a central logging facility where what you do on their phone goes back to a central server, and they were putting passwords in there, which you should never do. But there's no technical measure stopping you from putting sensitive information in logs. And if you don't pay attention to what you're doing, you often put something with sensitive information in there, like the whole request or something. And then they don't think about the fact that the log is not private, the log is on some server, and this kind of thing tends to happen. So your logs should be protected from people. We're doing a lot of Splunk now. This is also a big issue with Splunk. Splunk is searching logs, and those often have private data. So you just don't want everybody having full access to all those logs. You have to be careful. That's why Splunk has user permission levels. You can decide that low-level users can only see these logs and only high-privilege users can see those logs, because some of those logs do have really important stuff in them, like passwords and credit card numbers and God knows what. When you see some level of bad activity, you should alert people or block them at a firewall. This is what the BRO intrusion detection system does. It's not, doesn't have any fixed rules like a firewall. It just looks for malicious activity, and when it sees like 10 malicious requests within 5 minutes from one IP address, it blocks it for half an hour, and that's it. Whatever you're doing, if you're making too much trouble, they just shut the door on you for a while, and they say that's more effective than a firewall with fixed laws. Anyway, so web app firewalls can detect generic attacks of the kind we talked about earlier, like standard cross-site scripting attacks, standard SQL injection attacks, off just a list, and that's something, but they will not understand your app. Your app might have vulnerabilities that that firewall doesn't know. So, this is of some value, but it's not as good as a custom solution carefully designed with your code and your use case. The main reason people like them is you will, of course, meet compliance standards. The firewall is designed to meet PCI DSS or other standards, and when they scan your network to test it, they're going to be scanning the firewall, which is designed just to meet those standards, so you will pass the checkbox compliance, and that's what a lot of people want. Yeah?
I'm wondering what the definition of firewall encompasses. Is it more than just a permission, a table that has a list of permissions for given ports?
Yes, that's the generation 1 firewalls were just that, filtering by port and IP address. Now the modern firewalls are layer 7. They can look at the whole packet, and they know all the online services like Facebook and porn sites and known malicious sites, and they filter by Active Directory groups and everything else. A thing like a Palo Alto firewall is as complicated as a domain controller, and that's what everybody's using now. It's much, and you have categories like managers can go to shopping sites, but HR people cannot, and things like that. They're very sophisticated. And for example, they block our college. We have one at the college, Palo Alto. You can't use BitTorrent. You can move it to any port you want. It will look at the structure of the packet and block BitTorrent, your host. And that's the way that's the way everyone does it these days. Yeah.
Did you say that term again?
Palo Alto is the main vendor. Palo Alto is the current layer 7 leader in this industry, and they have totally changed the level of firewalls. They're the leader. Palo Alto firewalls,
Okay.
These guys have made the new super much better firewall, and everybody has upgraded to them, and all their competitors have moved up to a similar level, like Cisco and Fortinet and stuff. They're all kind of like these Palo Alto firewalls. They're very powerful. They're expensive. They're very complicated. There's like 10 or 20 pages of settings to make, but they integrate with your Active Directory domain controller, and they filter the traffic in a very sophisticated way. I remember even 6 years ago, people would complain, it's an invasion of your privacy to do deep packet inspection. You should only look at the address and the port number. And everybody has just abandoned that completely and gone to it, jumped into it with both feet. Everybody is filtering everything with the whole packet inspection, and they've forgotten any reason they ever wanted to complain about that. Because of BitTorrent primarily. Everybody's using up all your bandwidth with BitTorrent, and everybody got fed up with it, so they had to buy products that could really stop it. Anyway, good. So attackers are pretty easy to catch, really. They usually do things like run a vulnerability scanner that will send thousands of requests, trying minor variations of every little attack. So really, if you make any attempt to detect attackers, a lot of them are very noisy and easy to catch. So you've got a management interface someplace, like PHP Nuke, someplace WordPress has it, whatever you've got, it's got a management interface someplace. And you just have to log in with the administrator password, and then you can do things like shut down the server, just delete the app, download the data, and so on. So one thing you can do is attack the administration panel. Often it has just a password you can guess, or you can use a denial of service attack against it. There's lots of attacks to attack the administration panel of these things, and that's often a weak spot. So I got Cahoots for chapter 2. Let's take a look at that. And looks like 129S, chapter 2. Thought I had it. Well, oh, there it is. Just has a different title than I expected. Good. Yeah, we'll be right on the screen in a sec. There, go to kahoot.it and put in that number on any kind of device. There's even an app, but I don't know why you need an app, but there is an app, I noticed. I tested it for security and it was okay. There are a couple apps we use around here that are not secure. I was talking about last night, but this one didn't pass my very simple tests. They did not make like the top 3 stupid mistakes. Doesn't mean they're perfectly secure, but my very cursory inspection did not find obvious problems. Yeah, kahoot.it. It's Italian, I guess. Kahoot.com is where you go to make the quizzes. Kahoot.it is where you go to play them. Yeah. And while you're doing that, I'm going to put up a page to store the scores. All right. All right. Good. So I'll give it a few more seconds, see if we got more people coming. Moscow Mitch, yeah, he's all over the news today. Everybody's screaming and yelling about the impeachment. All right, 5 more seconds unless I see anybody new come in. I guess that's it. Okay. So, what process removes malicious portions of the input and continues to use the rest? Okay, that's sanitization, like you sanitize the water and then you drink it. All right. What process enables the website to remember who you are? Okay, that's session management. All right. What do you accomplish by logging in? That's authentication. Good. And what process requires writing code that can't be fooled? That's safe data handling. This is the gold standard. If your programmers actually knew how to write secure code, you would be the best. The only company I know that does this is Netflix. The Netflix security engineer gave a talk here, and I asked him, do you want to take some of our students as interns? And he said, no, I don't want your interns, and I don't want your graduates. We don't look at anybody. until they have 5 years of industry experience, because there is no training course, no certificate anywhere that teaches you to write secure code. The only way you learn it is in real combat, and we don't even want to look at you until you have done real work and learned how to write secure code on the job. And they're considered very secure shop. Anyway. So that's, okay, I think I know who that is. And your mom, I don't know who that is. And Will. Will sounds like a real name, although it might be a duplicate. All right. Anyway, I recorded those names such as they are. All right. And we're only about a half hour in, so we can carry on with the next bit here. I'll get at least partway through the next bit, and then we will talk about the extra credit projects and just do some SQL injection. So there'll be quite a bit of demo to do. I want to make sure you've seen the SQL injection and get ready for that project, which will confuse people if they haven't seen the introduction to it. So here's the fundamentals of HTTP. Hopefully you've seen this before in Net Plus or something, but the point is, it's this, the original purpose of this was just to display web pages, and it works very much like FTP that just fetches a file. So you send a request to the server, then you get a response. There is no session handling, no login, no nothing. It's just like asking for a file and getting a file. That was the idea. So the request is just plain text in lines. You get something, CSS, family, roboto, and then HTTP/1.1, and then you have the name of the host, and the first 2 lines are all you really need. But these other things are used by modern browsers, these additional parameters, to customize your request. And all right, so the referrer spelled wrong, and it is the official spelling you must use because it was spelled wrong in the RFCs and became the standard. This is the URL it came from, which is, by the way, pretty rude. This means that if you go to a website, you tell that website what previous page you were at, which is probably none of their business, but I think the original plan here was to see which of your ads were working. So you'd know which ad they clicked on to get here, but it could be seen as a privacy risk. And unfortunately, some developers use this as proof that you came from the expected previous page on my site, which it is not, because it can be forged, just like the caller ID field in a telephone call. You can make it look like anybody is calling, and a from field in an email. It is there for convenience, but you can't rely on it. But people often forget that. The user agent tells you which browser is being used. The original idea of this was that you could customize your page to show a different thing to each browser. And nowadays that is used, for example, for iPhones. If you have a phone, it'll notice that and show you a different page designed for a smaller screen. It can also be used to detect a lot of automated scanning tools and scripts and such. But also, like all these, it can be replaced by anything, by the user using BERT. You can't trust any of this stuff. All right, that's host name of the server we've seen before. You need this because the IP address might not be enough to uniquely identify the server. You can have many web pages share the same server. There was a time when you could not do that with HTTPS, but that has been overcome. And now many websites can all share the same HTTPS connection too. So you do need to know the host name of the server you're trying to talk to in general. Otherwise, it won't know what to serve you, even with the path of the file you're trying to reach. So the cookie is the big thing. And you see the cookie here with all this junk. That is the magic cookie invented by Netscape. It is any data you want to add to the request, and that's where the session state is typically stored. All this long random looking junk is some kind of number that identifies you, and it resends this cookie every time you go back to any page on the same domain, and that is how it knows who you are. That's typically how it's done. And you can put any kind of data you want in there, and often unwise things are in there, like credit card numbers and passwords and stuff, and data that's been encoded but not really encrypted or signed, and the developer thinks they can trust it because it's in the cookie, but the user actually had a chance to grab it and modify it, and that's how you get serialization attacks, where you have a string like an ASP or Java string that contains encoded data, and you can modify it because the developer adds the price on this page, adds your credit number and the card number on this page, then finalizes it on this page, and they don't realize that they're making a data structure which is stored in a Java object, and that object is being sent to the user and bounced back up. and sent to the user and bounced back up. So they now, at the end, they finalized the purchase using the price that came from 2 pages ago, which without them realizing it has actually gone to the user and come back a couple times, so the user had a chance to modify it. Now there are more advanced versions of serialization structures where that structure is actually signed cryptographically so the user can't modify it, but the older versions didn't do that, and you could actually modify things. So you could buy a product and then change the price, so when you actually make the transaction you pay a different price than the developer expected. What you should do, of course, is only use important data like prices from your known server data. You shouldn't trust anything that came from the user, but like the whole fundamental problem of all this is it's not obvious to the developer what data came from the user and what data came from somewhere else. And it's hard for them to keep track of that, and they often make the mistake of trusting things that came from the user. All right, so here's the response. Once you send up a request, you'll get a response. The first line tells you whether it worked or not. 200 means it was okay. I understood your request, and now I'm giving you whatever you asked for. That's the most common thing. So there's a banner at the top, which is very much like the request, and this tells you information about the server software. So it tells you it's an Apache server and what date it is and a bunch of cookies being set by the server. It's going to mark you so remember who you are in case you come back and do more, and various other parameters. You don't see any of this in your browser, but this is all sent to your machine and used. Pragma has to do with how it caches things, and you can set expiration dates on the cookies. And then you have a message body after this. This is chunked data down here, which sends some information. This is looks like JSON type data. It's structured data to just fill in like a headline in a card of not a whole web page, but a little piece of it. Trump campaign hints at softening immigration stamp. This is what you'll typically see in a mobile app. You don't actually load a whole page. You ask for a little data. It gets a little structured data and puts it in a field or something. What's that? I have a chat message. Oh, good. Let me see. Thank you. How well does deleting cookies work? Oh, that's a very good question. Deleting cookies takes them out of your browser so that when you go back to the page, it will forget who you are. The same thing is true of private mode. It does not protect your privacy from someone who does a forensic examination of your computer because deleted files are still present on the machine. I don't really think what the main thing about deleting cookies is if you're using a shared machine in a lab like this and you walk away, the next user who comes in won't open the browser and find that you're logged in as you. That is probably the only thing it does. I know a lot of people from the old days made a big deal of deleting the cookies all the time. And if they just sign out, it essentially would do the same thing. By the way, here's a fun fact that's very, very, very annoying. When you sign out, typically all it does is delete the cookie, but the cookie still remains accepted on the server. So if I stole your cookie, I can still get in the session even though you signed out. This is true of about half the web searches I tested about 6 years ago. I went through hundreds of them and found a lot of them, including Office 365 at that time. I don't know if they fixed it ever. A lot of people don't care. Signing out, in fact, even changing your password does not stop the old cookies from continuing to work. It's very rude. So if I steal your cookie, you're more screwed than if I stole your password. The only way you can get me out is to delete your account in a lot of services. I don't really understand exactly why that happens on the server. Logically, the log out button should invalidate the cookie everywhere. That's kind of what the point of it is. But in many cases, all it does is delete the cookie out of your browser, which does protect you from the next user using that browser, but it doesn't protect you from anything else. It's a very good question. And this is just exactly the point of this class. Simple little operations like logging out, you should think about what they should do and what they really do. And it's not as easy to protect users as it should be. Anyway, all right, good. So we talked about the pragma. All right, so get is what you do if you just want to retrieve something like an image or a web page. You can send parameters in the URL query string, but if you do, that's considered an unsafe place to put it because those are stored in the log and they're stored in the internet favorites and so on. Using a post request is a better way to send up secrets like passwords. Now, it doesn't encrypt things, but it puts them in a place where they won't just be stored in logs and in favorites and just all over the place and be on the screen so someone can just look over your window and see it. Post sends data in a below the request. So when you do a post, it's usually an action you only want to do once. So if you try to click the browser's back button, it'll ask you, do you really want to resend a post message? Because a post message might have posted like a tweet or purchased a product. And if you refresh the page, you're going to purchase another product or post another copy of that tweet. And maybe you don't want to do that. So head returns only the header and not the body. It just gives you that server information. Options shows you what message the server allowed, what methods it's allowed, which are typically like head and post and get, but usually not put. Put lets you send data up to the server. It is used by mobile apps, but it's often disabled. All right. And so you got a uniform resource locator with a protocol, then a : / then a host name, optionally a colon and a port number. And then you have path, file name, and then you can have a question mark and then parameters in the get URL. And those are those command line parameters that go in the get, which are not a safe place to put secrets, but they're commonly used to customize responses. RESTful URLs put parameters in the URL. So where logically you do this, have an app and then have a question mark, make equals forward, model equals Pinto. First, this is one of the many reasons why it gets so baffling. There are many incompatible random ways to send data to the web. So the logical way to do it would be this, but some people use this REST technique where they just put /forward/ Pinto. So they put parameters in so they look like folder names. So it's going to be hard to sanitize data if it comes in these strange formats. But there are no real rules. You can take any part of the request and write a server that will process it and interpret it any way you want. And there are several different techniques in common use. So it makes it hard to write a filtering engine that will tell good stuff from bad stuff. This is similar to another piece of madness, which is your browser accepts broken code. If you write a C program and you make a mistake, it won't run. It says, can't compile it, fix your code. If you make a bad HTML page, the browser just renders it anyway. It makes a guess and tries to fix it, so different browsers render it differently. This is kind of madness, but that's the way it is. And attackers learn this and use it. This is another way to defeat injection. You can just inject code that is wrong, but still works. You often don't need the bad characters. Like you should put a quote around the values of parameters, but you can often omit it. And if they're filtering quotes, you can get away with leaving it out. Anyway, let's try another Kahoot. That would be 3A, which I think is this one, and so it is. This is all good. Bernie is greater than Trump. Well, I have to agree. I'd vote for Bernie before I'd vote for Trump. What's that? Hillary doesn't like Bernie, I know. It's a strange sentiment and a strange time to say it, which kind of... I know, well, nobody much likes Hillary, and I don't really blame them. Hillary's not that impressive. Anyway, although I'd vote for her before I'd vote for Trump. And I did, but I hope to have a better choice this time. And I think I will. I'm not, but if I was, I would probably be the one they all hated. A lot of them hate me around here too. I'm not usually in the middle. Anyway, so. But I don't plan to vote for Trump, which puts me, I guess, on the majority around here. Anyway. So I'll give it a few more seconds. All right. So which of these is restful? That's the one. You take parameters and just put them in as if they were folder names. And I don't know why they do this stuff to us, but that's what they do. All right. Which parameters are stored in bookmarks? That's the query string, the part after the question mark in the URL. Okay, what portion is often get? Yeah, you probably know too much. It's sometimes called the verb. A probably more proper name is method. That's that's what they call it. That word before the URL. Anyway, such is life. And what method requires user confirmation when clicking back? That's post. All right. This is why these are extra credit, by the way. One could reasonably argue with some of these. And I hopefully will avoid being harmed so much by making them extra credit. So the imperfections of them is hopefully not as important. Ken Tan and Gary Lynn, these look like real names. Good, those people are going to get their points. Your mom, probably not so much. This K, I'm pretty sure that's Hey, it's K. I know who that is. Anyway, all right. So, all right, it's about 10 minutes. Let's take a break until 5 after, give you about 10 minutes, and then I'm just going to demonstrate the SQL injection, and we'll not finish this chapter today. So I'm going to stop the recording, but leave the share going to try to break the recording into 2 pieces. That may or may not work. And we'll pick up at 7:05.